Hi folks. Hello. My name is Dr. Cliffe Schreuders. I'm a reader in cybersecurity and director of the Cybercrime and Security Innovation Center at Leeds Beckett University. I'm going to talk to you about innovations in cybersecurity education, and specifically I want to talk to you about some of the technical solutions to teaching cybersecurity that we've built and that I've been involved in coding and creating. I'm also going to talk a little bit about content for teaching cybersecurity and what we do to try and make cybersecurity education meaningful and engaging and hopefully a little bit fun. So obviously I could say a lot more about myself, but just to say that I am a very much an open source software, free and open source software advocate and free culture. I love programming. I spend a lot of time programming and creating things. And I started hacking computers in the 90s when I was in like high school, I guess. And I would hack things and built all sorts of things back then. And recently I've just been reflecting, and every time we try and build educational experience for people, try and go back to that initial, what is it that really engaged me when I was first learning about cybersecurity? And I've not thought about this movie for years and years and years, and I don't think I've ever mentioned it to students before, actually. But I loved this movie, and I watched it recently, and it's a bit naff. There's loads of technical inaccuracies. But it just reminded me of that spark of joy that you get from the experience of hacking computers. And when back in the day, we didn't have any of the technologies then that exist now, like virtualization, where we can give you something to hack into that's safe and confined and legally, clear and all that sort of stuff. I think it's just reflecting on that joyful experience that you get from that first time that you hack into a machine. And it's not always fun. So don't get me wrong. Like sometimes it's challenging and it's hard and, but if what you're trying to do is solve a challenging, hard, interesting thing, hopefully the experience is that when you do eventually solve it, if you're not having fun, you at least get a deep sense of satisfaction that you've managed to do that and managed to achieve it. But I think it's what we can aim for, especially at the start of the education experience. Obviously we ramp up difficulty as we go, but especially when we think about how do we introduce these concepts, really, it's easy to make it fun because when you think about cybersecurity, there's inherently, it's adversarial in nature. You've got people that are defending, people that are attacking, you have black hats and white hats and red teams and blue teams. And, it's very adversarial in nature, which makes it easy to make it fun and interesting and engaging. And I think also something that's not really talked about very much is the fact that there's this sense that it's a little bit mischievous as well, which really taps into something primal as well, I think. And if you can manage to achieve that, then that is really useful. And in addition to making it engaging, interesting, and fun, really what we want to do is embed what's known as the security mindset. So the security mindset, if you've not heard that term before, is basically we want you to be able to think critically about a system as an attacker. So even if your job is to defend the systems, even if you are on blue team or whatever, if your job is defense and hardening, it helps so much to have that offensive mindset so that when you are thinking about a system, the first things that you're thinking about is, well, how would I go about breaking the system if I was attacking it? And that is just a really useful, to some of us it comes naturally. But even if that's not your first inclination is how would I break something? That then you can still learn those skills by being exposed to that way of thinking. So being given lots of challenges where your job is to break into systems and see those flaws. In terms of learning theories in pedagogy, there's a term called constructivism, which is essentially the idea that you build your knowledge based on what you already know in addition to what you then experience. So it's experiential learning. And in terms of cybersecurity, what this means is learning through doing and actually having an opportunity to put into practice the things that you're learning. And again, with cybersecurity, it's easy to do that stuff with cybersecurity. There's lots of ways you can get hands-on with things, but it's not how every university, for example, teaches cybersecurity. You can take a very theoretical approach, or you can take a very hands-on approach, or a combination. And what I try and do when I'm designing materials is we'll describe the theory, but then, and whenever it's possible, get students to put that theory into practice, because you'll get a lot more. You'll walk away having understood it fully and having done it, which I think is better than the alternative. So there's lots of things that we can do to actually give hands-on experiences where you can actually get your hands dirty and actually experience the thing. And obviously in cybersecurity, one of those ways is through capture the flag challenges. Capture the flag is an amazing experience. So again, if I'm talking about my history, I guess, like when I was an undergrad student, had the opportunity to participate in kind of early capture the flag competitions, and it's a lot of fun. It really is a good, so obviously there's competitions. You can do it as a hobby. There's lots of really great, basically it gives you that experience of having machines to break into, but it gives you clearly defined goals and objectives. You know when you've succeeded. There's a lot of really good things about capture the flag challenges. So it works as a way of engaging learners. But building those challenges is really hard work. So having built loads of CTFs and CTF-like challenges over the years, I can say from experience, it's a lot of work, it takes a lot of time. And typically what it would look like normally is that a CTF challenge gets created and it's very much a manual affair. Maybe you'll basically install some software, configure it in a vulnerable way, or install vulnerable software, or maybe write some vulnerable code. But really, when you think about it, that can only really be used once before it can't really be experienced again without taking away that problem-solving element. It becomes a memory exercise. So one of the things that we've built is a open source software called Secgen, and it generates randomized challenges. It generates virtual machines that have meaningful security challenges and CTF scenarios. And importantly, has randomization, which I'll talk about in a minute. Huge library of content. Again, I'll talk about that in a moment. We have a front end called Hacktivity, which is like our online platform, which essentially manages all that back end infrastructure, gives access to all of the virtual machines. It's a hosted platform. So it's kind of like, like a website that you log into, and all those VMs are like running, like infrastructure in a data centers. So I guess the important thing about the randomization is that it makes it so that you can do something, for example, like give students a challenge, and they might all be a little bit different from each other. We can decide how different they are. We might decide, well, we want to be able to teach a class easily, so we're going to give them basically the same thing, but give them all different flags. Or we give them all something completely different, actually randomize the kinds of vulnerabilities that are there, or randomize the thematic content of the challenge, or randomize a combination of these things together, which can create something that's quite interesting. So it helps from the educational point of view, but also from I just want something to hack into. What it means is that we can generate these hacking challenges. If we want to make them very random, we can just give you challenge after challenge of something that's quite different. And so I'm not going to go into this in detail, but there's a few different ways that we do randomization. It's also modular in nature. So what that means is that we have like these reusable code-based components. So rather than being a manual thing where we will go in and have to install Apache on a server, for example, it's just one line. We want Apache on this system, and basically we're building from these building blocks that we've already coded, and so that it makes it easier, it makes it more efficient. It's harder to set up in the first place, I guess, than manually installing Apache versus writing the code to install Apache. But in the long term, it's a lot more efficient and it's a lot more powerful of a solution. So it makes it easier to build those challenges. We as a team and me and I as an individual really believe in open innovation. So Secgen is open source software. You can find it in GitHub and play around with it. If you run it on your own machine, you'll be provisioning VMs that are on your system. And we use it at a much bigger scale where we're provisioning into our cloud, like virtualization platforms and things. So the technology stack for Secgen looks a bit like this. The Secgen's coded in Ruby. It uses Vagrant to kind of manage the way that we interact with VMs. We use Puppet for making system-level changes, for like installing software, for example. Puppet Librarian helps us manage dependencies. We have local code that's written in Ruby that will generate content and encode content. So, for example, those modules, one might be as simple as a base64 encoder. And we might have another module that is a security vulnerability. That's an FTP remote execution vulnerability. We stack those things together and pop a flag on top and, a couple of lines of code, tell it to build. And then we've got a VM that has a remotely exploitable vulnerability on it that has a flag that's base64 encoded or whatever that you'd find as a result. So we also deploy to VirtualBox, or what we use is we deploy into our OVA infrastructure or our Proxmox infrastructure. So we over the last year or so, we've been making a move to Proxmox. So OVA is a Red Hat-based platform. I've spent many, many hours coding all the Proxmox stuff. So essentially, now we have multiple clusters, one running OVA and a number of clusters with servers that are running Proxmox, which is future-proofing for us. And Proxmox has been a really great programming experience. Actually, the APIs are very nice to work with. So we have a huge amount of content that's part of Secgen that maps across to CyBOK. So the CyBOK is the cybersecurity body of knowledge, and some of the sorts of things that we cover. I know there's some of our previous or current students in the room, so you know this already. A couple of you, but yes, we've got things like ethical hacking, penetration testing, web and network security, system security, incident response investigation, malware and reverse engineering, software security and exploit development. So how do we choose what to cover? Well, we've done this mapping exercise across to CyBOK. So we are one of only 10 universities in the UK that are currently NCSC accredited for an undergraduate computer cybersecurity degree. There's a very rigorous process of basically mapping everything that we do across to CyBOK and demonstrating all these different concepts that we map to. And as part of that, we looked through like every lecture, every lab, every assessment, and mapping it all to all these different concepts. And then after that was a useful experience. We renamed modules to make it clearer what's inside them, and we even added a new module to cover some stuff that, on reflection, we thought we should be covering in the degree. So it was a really useful process to go through, but also I then won a bunch of research grants or development grants through CyBOK to basically bring that mapping through to Secgen. So now within Secgen, every CTF challenge, every scenario, every lab in Secgen is all mapped across to CyBOK. So for example, here in the GitHub page, we have a cross-index, an index here of like different CyBOK knowledge areas, and you can see within that all the different scenarios that are within Secgen and how they're mapped to these different concepts. And then if you actually like look at one, for example, you can actually see specifically the knowledge areas, topics, and keywords that are mapped to that. And actually, if you want to, you can even click through and look at the source code and see how we actually generate the virtual machines. So other recent things that we've been doing is making use of ChatGPT. So ChatGPT is I think it's amazing. It's an amazing piece of kit. Large language models are going to change the way we work. They're going to they've already made me more productive in programming that I do. There is a separate discussion about how we update education accordingly. I think for one of the ways is do more of these kinds of like technical challenges where you actually need to sit in front of a machine and complete the challenges because, but what we're using ChatGPT for at the moment is to generate some narrative content to kind of breathe some life into these challenges. So if you've done CTF challenges before, often you'll basically hack into a machine and that's the end. You get the flag. Cool. What we're trying to do is have some bit of narrative content, a bit of flavor that we add to those machines. So, for example, we've got a scenario where you're basically trying to thwart this evil organization's plans for world domination. So you hack into the machine and you can find some financial records and the plans that they have for like taking over the world. And, just a bit of fun, but it just like makes it only just adds a bit of life to what we're already doing. We also have Hackerbot, which is basically a interactive chatbot. It's not based on a large language model, and if you ever have a conversation with it, you will not be impressed by its conversational skills. But what it can do is attack your machines. So basically, it's running in a separate copy of Kali Linux, and it will actually fire off Metasploit and actually attack the students' VMs using real exploits and things. And then your task is to do things like defend against the attacks that Hackerbot's carrying out. Or the example on the slide at the moment is setting up IDS rules based on something it's asked you to do. And then, whether you stop Hackerbot from carrying out an attack or you investigate, figure out what Hackerbot did, or complete whatever task it's asking you to do, in this case, create a snort rule, then when you succeed, it'll give you a flag, which is basically a way of like CTF-ifying the kind of defensive and investigative stuff. So Hackerbot is our online lab infrastructure kind of platform stuff. We've had over 1,000 of our students have now used Hacktivity. Every year I spend many hours, and so do other people on the team contributing to these projects to make things better. But yeah, so we keep improving Hacktivity, but we've built up this like lab platform. Some of the features is we're about to launch this very soon daily hacking challenges. So based on what I was saying before about having these very randomized challenges where we can just encourage people to interact on a daily or a weekly basis. And in light of that, we've also like bringing in streaks. So you can see like how many weeks in a row have you completed, how many flags and completed challenges and things. Compared to other platforms, it's a really good desktop experience. Spice is basically like a better version of VNC. And if you've used a lot of the other products that are in the same space, they're often like a web-based system, which can be very frustrating to use. And also, it's a nice desktop experience as opposed to just using OpenVPN or something like that. So it does a lot of stuff. It provisions VMs, has multi-factor authentication, allows you to take snapshots of your VM so that you can, roll back if you make a mistake and brick a VM or whatever. We've got leaderboards and like scoreboards and all the rest of it. It gives you a safe lab environment for learning about cybersecurity. So let's see how this internet connection is going. I'm not going to do it's not a long demo or anything, but just a little peek at what it looks like. The platform looks a bit like this. So you can see this is the introduction to ethical hacking. And, you can basically go in there and see some leaderboards. You can grab some VMs and start them off and start hacking. Just kind of wrapping up. Recently, we won a grant through Cyber ASAP to look at commercialization. So we won the Academic Startup Accelerator Program, Cyber ASAP. And through that, we basically did a whole bunch of development. And so, we had the funds to have more developers working on the platform. We created more hacking challenges, including open source content, and basically getting it ready to have commercial customers. And I'm not going to talk about it in detail, but we have I'm happy to say that we do have our first commercial clients kind of confirmed at this point. So we're taking it forward and entering the commercial market with it as well. So in conclusion, and if you basically learning cybersecurity should be enjoyable and engaging, maybe fun to start with, and hopefully fun, if not deeply satisfying if you do it right. Use CTF challenges. It's so much. It's so good. It's such a good way to do things. We publish extensive open source software. We're going to continue to do that even as we start commercializing some stuff. Open source is really important to me. So the actual core framework and the challenges and stuff are going to stay being open source. We're going to continue to contribute to the community in that way. And Hacktivity provides like a hosted experience of all this stuff. And if you want to know more, you can talk to me afterwards. And that is the end of the talk. Thank you.